Hello everyone, this is Dr. Zia Tahir, and today's tutorial is about 2D cross analysis in Abaqus 2020 version. In this video tutorial, I'll explain you about steps in Abaqus. Like the first main step is modeling procedure, then analysis, and then results. So when you open Abaqus 2020, so this is the interface which you can see, and if I now, so you have model, then you have analysis, and both model and analysis are in model module, and then in results you have further few other things. So in model you have some steps. So pretty much to perform any type of analysis in a backend, so you have to follow the steps in a sequence. And then in analysis, so you need to run job or check. So these are the content of, like, the first one is modeling procedure, then analysis procedure, and then visualization of results. So one important thing when you are going to use Abaqus are units, because the Abaqus, whatever you are going to input, so it takes them as Newton meter Pascal, or it takes them as Newton millimeter or megapascal. So when you are entering dimensions or modeling, then you need to make sure that you are following Newton, loads, dimensions in meter, loads in Newton, and all pressure or stresses or uh, modulus of elasticity or mechanical properties, like all the modulus in Pascal, or you can use that Newton, millimeter, and megapascal. So for this video tutorial, so I take that book, Introduction to Finite Element Analysis using MATLAB and Abaqus. So this is a book which I am following for examples and problems. So finite element analysis using MATLAB and Abaqus, and then this one, chapter 2, is about bar element. So chapter 2, bar elements, from Introduction to Finite Element Analysis using MATLAB and Abaqus. So there is an example in this chapter, so I am going to follow that one. So this is very simple 3-member truss. That is a 3-member truss, and these are the properties of that. Modulus of elasticity is 200 gigapascal. Radius of each member is 25 millimeter or 0.025 meter, and consequently from there I got cross-sectional area 1963.5 millimeter squared. So now the first step are the units. Not the first step, but it is like you need to make sure before starting. So before starting, you need to make sure that you have set up unit as standard Newton, meter, and Pascal. So like all these, load is in kilonewton, so you need to insert that as Newton. Then dimensions in meter, and then modulus of elasticity in Pascal. So the first step, or not the first step, but is a preliminary one. So you need to first of all set work directory where you want to save all your model, and then analysis results. So for that one, I have already created a folder, chapter 2, somewhere, and now I want to set that chapter 2 as work directory. So I'm going in Abaqus, so file, and here you have set work directory. So by default, it takes C and temporary uh, folder. So you can then from here, yeah. So, so that I have week 9 and chapter 2 in that. So I okay. So now it's Google in my Google Drive. It is like whatever the folder I want. So that everything will be saved in my work directory, which I have already set. So once you have set work directory, then you can start in Abaqus. So the first step then after setting work directory is you need to go part and you need to set that part. So I have here in the model, so I can create several models and I can name them. So let's say I am going to rename that model as example. Example chapter 2 or chapter 2 example. So it said that you can't use that spaces, so then you need to use the S or underscore for that. And then the problem is okay. So in the rename option, it is chapter 2 example. Now, I'll go to the part and I'm going to test that. So when you click on parts, I have different options. It says that part 1. So I can name it as Truss or I can just leave that as it is. So it is 2D and then deformable. 2D deformable and then cell. And approximate size. The approximate size is like in the problem it is 6 meters. The approximate size is like a 6 by 4. So what is usually done, you need to take the maximum dimension or maximum length and then times it with 2. So let's say I am going to put there as 20. Okay, so now a grid has been shown. Now here I have different options. So of drawing, so this one is for lines, circles, then rectangle, and then all other options. So my problem can be solved easily by drawing 3 lines. So I'm going to take here as origin, and with this create line, I'll start from here. This is origin, and then I can move it in any direction. So as you're moving in horizontal direction, so here you can, when you reach here, so you just right click and create a horizontal line. And from here, you need to go to 4, 6. So there are different options. Either you can go from here, or what you can do is otherwise you need to enter the coordinates of next point here as 4, 6. So you will have now that is the second point, and then you can just join it with mouse, or you can enter 0, 0 there. So that is now that's the first, and then right click and cancel procedure. After right click and cancel procedure, and here done. So now in part, uh, this is I named it 12, and then I test that one. Okay, so here in part test, and then you need to next step is you need to assign materials. So you need to go the next one here, material. So we can name that material or we can leave that as it is. So I'm going to give it steel and then mechanical and then elastic because we are using elastic material and Young's modulus. So I am using standard unit as Pascal, so that is 200 e raised power 9 and the Poisson ratio is 3.3, which is most of the field. So that is now I have assigned there in material as field. So the next one is section. So in section, uh, I can leave it as section 1 or you can name it anything. So in section, I have beam and then truss. So when I'm using truss, so what is required? Only cross-sectional area is required because the of stiffness matrix for bar element that need area. So area cross section is for that one 1963.5 millimeter squared. So 1963.5 e raised power minus 6. So that is now I have created a section and which is section 1. If I double click on that, so it will give me that what I have input as a section. So the next one, once I have created section, now I will go back to the part. I need to in section I have to find section and then I can do mesh. So further you can create profile where you need like for B, so you need to create a profile there that what is the profile of cross-sectional area. Then I go back to the part and I'll assign section. So section assignment, when I click double click on section assignment, so it will select the region to be assigned as a section. So it says that create a set. So I select that all and I select done. And now it is asking me that which section you want. So I have only one section. So and then it is now section has been assigned and you can see that the color is going to change. So done. So once you have assigned section, so you can see that so section 1 is correct, that is being assigned. Now the next one you need to mesh it. So for mesh, what are first you need to seed that, then you need to mesh part and then assign element type. So in mesh, I double click on that and then it appears that mesh menu. So here it is seed part and it says that seed edges. So sometimes you need you can seed and if you keep click on that, so you will have two options. One is seed whole part or delete delete seed part. So I'll go here. Here it is a seed edge. So I select that one and then if you select the region to be assigned local seed, so I say done and then it gives me different options. So the basic method is by size or by number and then bias. So if there's no bias, I will set none. So because it's here, this one, this example that uses one element between the nodes. So I'll go method by number and number of elements between nodes. So I have selected that as 1. So I applied it and then you can see that small rectangle. So I can increase to 2. I apply, so it will be between two nodes, it will create two elements. But I'm going with 1. So apply, OK. So it says that. So done, my color has been changed and then next one I need to assign element type. So if you select the region to be assigned element type, so I select that whole and then done. and the standard one, and then in the family it is Truss, so standard, linear, Truss, and the element is T2B2, so a two-node linear 2D Truss. So now it's done. So the third step in part, the next step, like the assigned and match seed part, match part, and assigned element type done, and then I'll go to assembly. So in assembly, I need to assemble different parts. So because here I have only a single part, so I'll go to assembly and then instances. So it says that create instance from parts or model, that with the very basic one, it is first. So like whatever is the part I have, so I click OK, and then you can see in instance it says that plus one. And now the next one is I need to assign steps. So steps are basically loads. So step one, you can name it or leave as it is, and initial, and then you have procedure type is the general procedure or linear perturbation. So I'll go for general, and then in general I have different types of loads. So because I'm going to perform static analysis, so for that one is static journal I need to select, and then continue, and then further it says that with the time period and nonlinear geometry, so you need to keep that nonlinear geometry off and rest all as default. So now once you have added a step, then the next one is, once you have created that step, like you have field output request. So based on that, what you have modeled and what is uh, which type of problem you are solving. So then you can have here field output request. It says that stresses, then strain, displacement, velocity, acceleration, forces or reaction, and then contact. So uh, whatever you need, so you need to select that one. I don't need contact, so I leave that. And then based on that, I have here history output, and here it is just energy. Okay, so you can leave history output and field output as it is. So the next one is you need to apply load, and for that one you have next step here load, and you can name load or you can leave as it is. And then step, it is step one because I have defined here step as static journal, so the category is mechanical, and then it is concentrated force. So I'll go continue. It says that select the point of the load, and you can see that the load is being applied there. So it's a 12 kilonewton in horizontal direction. So I select that point, and then select the point which is being selected, done. Then it says that concentrate is force 1 and concentrate force 2. Here I want to explain that, like here you can see that you have x, y, and z axis, but here uh, Abaqus takes that x-axis as first axis 1, y-axis as 2, and then z-axis as 3. So I have force 1.2 e raised per 3 of 1200 kilonewton in horizontal direction, and I have none force in vertical direction. If I leave that empty, it will automatically consider that as 0. So it's okay. So once I have applied the load, so here you can see, so that load is being applied. So I can, if I need to edit that one, so I can edit that, like if I want to reverse direction minus 1200, and this direction is being reversed, like as I could edit, and then again I'll say it as, and then I can change its location as well. So that then is the boundary condition, and in the boundary condition I have here at this node, it is roller sport. Sorry, pin sport. So I could go boundary condition. It's a boundary condition one. So I can say it has pin sport and then initial. So if you go step one, so what will it will in simple problems it will not have much effect, but in complex problems it create problems. So then you need to go initial that this boundary condition is applied at the start, and the category is mechanical, and I'll go for displacement rotation and continue. So at this node, I select that, select the region, so I will select that node, it's done, and then add, because it's a pin port, so all these displacements, they are 0. So for 2D, it is U1 and U2 are 0, and you can leave that U3 as it is, or you can uh, check it, and then you'll have here, like you can see that, so horizontal, vertical, and then rotation, that is 0. So here you can see that the same, and now the next boundary condition, I can go for a roller, and here is again initial displacement, and that roller sport, it says that check the region of the boundary condition, so I select that one, it's done, and then on roller sport I have that horizontal uh, displacement as non-zero and other two are 0. So then, so this one is, now I have done all these steps. So now modeling procedure is done. So, and next is the analysis procedure, and I'll go for job. So here is all that model is done, and then I'll go to the analysis, and in job, I double click on the job. So it says that norm name. So I'll go set it to example and continue. It says that there is something wrong, so you can't give the name. So I'll go like that, set it to example, and leave that everything as it is. So in job, so you have kept it to example. So in job, you can go for create job. I have created that, and the next one is data check and submit. So sometimes, because it is a very simple problem, but sometimes when you are going to uh, model complex geometry, so then uh, for analysis, it may take several hours. So then the data check is important. It says that following part is not matched. So the following parts are not matched. So I'll go back there in the data check, and then it says that mesh is empty. So it says that mesh is empty. So not sure that what happened when I did it previously. So it is being C, and then it says, yeah, it's now meshed, and then it says it's done. So I'll go back again and I'll check it, data check. So it says check submitted, then it says check running, and now the check is complete, and it says that it is not being aborted, but previously it was aborted with some error. So now there is no error, so I'll go to submit job. So say okay, so now the job is being submitted, and now it starts running. Take some time, and now the job is completed. Once the job is completed, it means that your second main step analysis is being done, and now you need to go to results and results visualization. So you can click on that one and on the job, and then you can go to the results, and here you can see the results, or you can go to result section, file, and then open ODB, and that is ODB, and then you can open it from there. So now that is your model. So common plot options, so you can go here, common plot options, and on common plot options like deformation scale factor, autocomplete, you can change it. Then color and style, labels, so you need to show element labels, and then show node labels. So element labels, let's say I'm going to change the color to red, and then node labels to dark blue. So, or you can use that default. So I'll apply it here, and then now you can see that it is node 1, node 2, node 3, and node 1, 2, and 3. So, sorry, elements. So elements are red, and then nodes are as blue. So now I can go to deformed shape. Okay, so this is undeformed, that is deformed shape. And then here you can see it is plot contours on deformed shape. So that is like von Mises stresses, or if I click on that, so I have option of both deformed and undeformed. And here you can see the stresses, and then you can see those concentrated forces. Okay, and just click on that, and you can go to the deformed one, and then displacement. So these are the displacements in magnitude, and then here are the stresses, and then you have these strains. So from here you can visualize all the results, whatever you have input in the here field output request. So then if you want to get a report of that, so or you can get all any plot. So the next one, you need to go to report and field output. So here you can go to report and field output, and here it says that you'll give variable and position. So integration point, centroid, then you need to select unique node. Unique node is a concentrated force. I am only interested in concentrated force, and then strain, then let's say reaction force, and then spatial. So and then if you will, there are different options here. So you can just click on all. Okay, so if you see that tick, it means that you have selected all those. So you can, and then the setup uh, file, file name is Abaqus report, and it is going to, it is in the same current folder chapter 2. So it is detailed report. So I can go like chapter 2, chapter 2. So I give it name chapter 2 example full report, and I'll go OK. And in the work directory of chapter 2, I can see somewhere that is report is being created, RTP. So I say apply, and then once apply, I can see that it is report created, and then I can visualize that report. So node label 1, 2, 3, concentric force magnitude, then it's horizontal x-axis, y-axis, that is the report complete, and then I can go there, and I can just check the selected one. So like as concentric force 1 and 2, and displacements, all these just 2 I need. I can go to the setup, and then I select there instead of full report, I'll go here with report. Okay, apply, and I can see that this short report is being displayed there, like as node label, constant report 1 and 2, and then displacement u1, it is mean that in horizontal direction, u2 in vertical direction. And these are very small values like -33, -33. So these are just zeros, and again these are very small values, they are just zeros. Okay, so in the work directory, whatever is the folder, so you can see both reports are being created there. Okay, so I go okay, and now at the start or right at the or at the start, so you can just select your save your model, and model database, it is being saved in your current work directory, so it is set to example. So now you can see that one CAE file is being created, set to example, so that is a CAE file is being created there, and then this is the ODB file, it is being created. So I hope that this tutorial is helpful for you. So you can comment for your feedback. Thank you very much.